and all the participants in the AICTE sponsored short-term training program on the title Computer-Aided Drug Design, a customized and innovative solution to the greatest challenge in chemistry in 4th phase. Today, we have Professor Dr. Manju Singh ma'am from Pandit Shukla University, Raipur, Chhattisgarh, and she delivers his talk on computer-assisted experimental designings and how they are useful in the pharmaceutical dosage form development. Before starting off expert talk of ma'am, this is my moral duty to introduce the ma'am to all the participants. Dr. Manju Singh madam is currently working as assistant professor senior scale at University Institute of Pharmacy, Pandit Ravishankar Shukla University, Raipur, Chhattisgarh, India. She did her postdoctoral research from University of Mississippi, Oxford, USA. She has a rich experience of 17 years of teaching and research. Her prime research area includes the designing strategies for protein and peptide delivery, topical systems of autoimmune disorders like psoriasis, rheumatoid arthritis, inflammatory bowel diseases, and experimental designs using advanced statistical and mathematical modeling methods. She has 80 research and review papers published in international and national journals. She has more than citation of 3,500 with the H index of 26 and I-10 index of 48. She has authored 1 book and 2 are in press with the Elsewhere and CRC. She is engaged in the research project focused on the studying of the pathophysiology and devising new treatments, mainly for the autoimmune disorders and inflammatory diseases, in collaboration with University of Mississippi, Oxford, and Deccan University, Australia. She has successfully completed projects funded by the Indian Council of Medical Research, ICMR, University Grant Commission, UGC, Chhattisgarh State Council for Science and Technology, and Department of Science and Technology. She is a recipient of DHR ICMR International Fellowship 2014 and 15 and number of the awards at state level and excellence in research like Young Pharma Woman of Chhattisgarh State 2020, Young Scientist Award of the State of Chhattisgarh 2006 in the field of biotechnology. She has been bestowed with the Best Teacher Award of Pandit Ravishankar Shukla University, Raipur. She has Honorable Joint Secretary of Indian Pharmaceutical Association, Chhattisgarh branch. She also has worked as a Secretary, Association of Pharmacy Teachers of India, APTI, Chhattisgarh branch, and co-convener of the APTI Women Forum. Ma'am, we welcome you for today's expert talk in the COP BELA family. Welcome, ma'am. Over to you.
Thank you, Dr. Shailesh, for such a modest introduction. Thank you so much. Thank you for the opportunity for inviting me to interact with such wonderful participants. Good morning to all of you. So if you'll now allow, I'll start with my presentation.
Please.
Thank you. So it is on computer-assisted experimental designing. I'm going to share my screen. My screen is visible to all of you. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Okay, thank you.
Please do it on the presentation mode.
It is on the present.
Yeah.
Is it fine?
On presentation mode. Ma'am, please use that.
Okay. Okay, so I'm going to present an overview about the computer-assisted experimental designing. See, amid this COVID-19 havoc, I think the importance of computer, although it has been very well realized earlier also, but now this has come up the realization has come up even far more with the advent of this havoc of COVID-19. And especially this is so with the teachers like us who are sitting at home and delivering the lectures to students. It is very difficult to perform the experiments in the lab, which we otherwise do. We ask the students to do the practicals virtually. So I think this is one of the approach which we can use with our students to at least do the designing part at home using the computer, and then we can go for actually the actual experiments in the lab. So so first of all, I'll just start with the what is actually the what are the experimental setups that we need to do, and what are actually the experiments. So these are actually the set of all the entire systematic procedures that we carry out along with the control conditions to elucidate the effect of any component which is actually unknown to us, or to test or establish a hypothesis which is there based on the observations, or to illustrate the effect, any known effect of any factor. Okay, so in this, there are actually three main components of any experiment. The first is actually the input, the process input. That means the factors that we actually work on to look for its significant impact on the output. The second is the target, the output that we actually desire for, the kind of result which is desirable or desired by us. And the third is actually the uh, the designing of experiment, which is actually the crucial part, because earlier what we had been doing is just the trial and error. So principally there are just three approaches of experimentation. The first is the trial and error method, the second is actually the one factor at a time, and the third is design of experiments. So what we were actually doing earlier, it is the trial and error method, in which we just simply used to try for certain things. We used to chalk out the errors, remove it from the main experiment, and then we just continue with our experiments, which is actually quite time taking and a tedious process. So this we do in our home also, when we make some goodies or something like that. That is based on trial and error, and based on that trial and error, ultimately we are at the end, we are with some positive end product. So but otherwise this is not expected from a pharmaceutical scientist, because we cannot wait for too long for the results to come, right? We want the optimum result with the maximum reproducibility, with the minimum of errors, maximum precision. So trial and error method is now obsolete. Another method that we take up in during the experimentation is a one factor at a time. So as it is evident from the name itself, that in this we just take up the one factor at a time. That is, we just study the effect of a single factor on a particular component, okay, or its effect on the output. So this is again now obsolete, because it is again time taking process, and we cannot study the interactions by this process, right? Because if we use two or three factors at a time, we can actually analyze the effect of the interactions between them, which is otherwise not available. This kind of data is not available to us using the one factor at a time. Right. Next is actually the design of experiment, which is actually the kind of experiments that we need to follow now, and we are following. Actually, most of the scientists are now working on this particular line of experiments, in which we work on number of factors. We try to screen out the number of factors at the initial level, and then on the basis of those screened factors, we then pick a few factors which are crucial for our experiments, and then we look for actually the optimum combination of these factors to look for actually the optimum results or the desirable results that we want. But why is this designing so important to us? So I've quoted it by using a simple thing, that if we, for example, if we want to make up a cake. So when we want to make up a cake, there are certain factors which are there in our mind before preparing the cake. So the first is actually the key components in terms of formulation. So that includes actually the sugar, the flour that we are using, the egg, and sometimes if we don't want to use the egg, we use the oil for that purpose, then the baking powder, right? So these are actually the formulation components that we actually vary depending on the type of cake that we actually want. Another variable that is actually there is the processing variable, which is processing variables are like the oven that we are using, its temperature settings which are there, the time that we are using for its baking. Okay, so these are all the factors that play an important role for actually getting the final output, which is actually a cake. Now the response or the final output that we desired out of this cake is actually it should be, obviously it should be tasty. Its color, its appearance should be so appealing that by just looking at it, we should feel, we should be tempted to have it. Then it should have the unique consistency, the softness, the texture, the fluffiness that we desire from any cake that we want to have. So basically, the factors are actually the variables which are independent variables, and the response is actually the dependent variable, which is actually the variable dependent on the interaction of these factors or the inputs that we are taking up. Now, coming to the factors, simply these are actually the inputs to the process, and they can be of two types, that is either controllable or uncontrollable variables. So here in this case, the example that I have taken up is of a cake. So the controllable factors are actually like the amount of the flour, the eggs, the sugar, the processing variables like oven temperature, the baking time, the settings that we do on the while working on it. Okay, the next is actually the level. When we talk of level, it actually represents the settings of each factor in the study. So this could be actually the higher level of something, like we are taking up the sugar, for example. So the amount of sugar, it is the maximum. We set up certain limit for this. That is a maximum level of sugar. That is, for example, if we pick up the 1 cup of sugar, then the minimum, that is actually the 2 spoons of sugar. So by this way, we actually set the level or the limit for the amount of anything that we are taking up for our experiments. So if, for example, if we talk of our pharmaceutical experiments, we normally set up these levels by means of our preliminary investigations, our literature survey. So on the basis of that, we set these levels as a plus for the maximum and the minus for the minimum. Then comes the response, which is actually the output of the experiment. And in this, I've told you that in case of, like we have discussed about the cake baking, so obviously it should be tasty enough to or it should be appealing enough, so we should have it. So similar is the case with the whether we are preparing the tablets, the suspensions, or anything which is there of a pharmaceutical composition. It should really give out the response which is desirable to us, and this can be obtained by means of the design of experiment technique. Now, so why is there the need to go for these designing of experiments? I've told you, first thing which is very important is that it reduces the time to design. We cannot keep on doing the experiments, cannot keep on lingering the experimentation for a longer time just for the sake that we want to get a particular product. It should not be like that. So designing is very important from the time that it actually reduces the time to design. Second, it improves the reliability. We get the reproducible results each time we try to actually produce the product using the similar line of action. It to get the actually the product and the process robustness, to reduce ultimately, because the time is getting reduced, the number of experiments, the runs that we are doing, they are being reduced. So ultimately, this actually reduces the ultimate cost of actually the production. Then the last thing, which is even more important, is that we get the maximum yield of experiments. Okay, so in a way, we can say that designing of experiment is actually important to systematically investigate the key variables that actually affect any experiment or the output of any experiment. So this is about the design of experiments. So the major theme of my talk is actually the use of computer in the designing. See, the computer has really, the technology has really facilitated our life in such a way that we know that the maximum designing component, they actually involve the mathematical analysis, whether we go for the designing of the basic components, the final results when they come up, then we need to go for actually the analysis part, which actually involves the mathematical calculations. And we are aware that about 80% of the people in pharmacy, they come from the bio background. So it is okay for those 20% of the population, the pharmacists who are from the maths background, it is very easy for them, okay, to understand or to perform these calculations. But for those who are really from the bio background, it's really difficult part to perform these calculations. Even I'm from the maths background, but if you'll ask me to perform these calculations relating to experimental designing, so it is, I'll also say no to them, because it is quite time consuming and a very tedious affair. So computer has really modulated our life in such a beautiful way that we can now perform the multitude of calculations, the difficult of calculations in no time. So really thanks to the technology. Now, this is in general about the process or a system when we design any experiments. So the first thing is actually the input, the independent variables that we put in together based on our preliminary investigation. We put that into a process to get actually the output. So in this, there are various factors which are involved. So controllable factors is the one that we are actually taking up. For example, if I want to prepare a suspension, the controllable factors are like actually I want to take up the concentration of the suspending agent, okay, the major the component which actually makes it a suspension, the major drug concentration, right? Then the volume of actually the solvent into which it is prepared. So these are all the controllable factors which we can actually control. But then comes certain uncontrollable factors which are not in under our control, and these are also known as a noise. Okay, so we cannot avoid them, but we can keep them to the minimum. For if we say like if we are performing an experiment on day one, the temperature and the humidity conditions will be different in the day one then as compared to that in the day two, day three. So these are certain uncontrollable factors which we cannot actually control, although now the well sophisticated labs are there where everything is actually controlled, but still there are certain time it happens that we cannot control the things. So in that case we need to adopt certain blocks in the model. Okay, so then comes actually the role of the design of experiments. Now the key methodologies, key terminologies which are important in this point is actually key terminologies which are important in this, they are actually the interaction, randomization, and the fourth is actually the blocking. So I just want to remove this. Okay, so the first thing is actually the interaction, which is very important and the key point for this experimental designing, because in this we can work on a number of factors at a time. See, there are certain experiments, like normally if you remember the kind of experiments that we do in our B.Pharm labs and M.Pharm labs, we normally work on actually the single factor at a time. But when we go to the research level, that is not sufficient enough. We need to study about the interactions also. So these interactions are actually studied by means of the interaction plots that we make up. See, again, the interaction plot making is a quite tedious process. So by using these computers, we can simply make up these interaction plots in a well-defined way where we can actually analyze the results wonderfully. So in general, when we talk of these interaction plots, if there is a parallel line between the two factors, that indicates that they are never going to interact in any way during the processing. So that indicates that they are non-interacting. There is no interaction between them. That means neither of the factors are affecting the actually the effect which is produced by the other factor. Now another thing is that if they are in a little slanting way, or if there is a slope, that means they are going to interact some way or the other with each other. Like if we see this graph, if you can see this over here, see, this indicates this low end indicates the low and the high levels of A factor. For example, if we are taking up, then B, it indicates the low and the higher end of actually the B factor, and this is the output that we desire. So how we are going to study about the interaction? It is simply by actually we are going to study about the effect of this EA factor in the presence of the high level of B. It will be 45, the high level of B minus that of the low level of B. So it will be the net effect of A in the presence of high level of B factor will be 45 minus 20. So it comes out to be 25. Now, if in the similar way, we have to analyze about the effect of A factor in the presence of the low levels of B. So it's going to be 55 minus 50. So that comes out to be 5. So the net or the main interaction effect is actually the effect of A at the higher level of the interaction at the high level of B with respect to the interaction at the low level of B. So this comes out to be 25 minus 5, which is actually 20, and then we take out the average, which is 10. So the net interaction effect between these two factors comes out to be 10. So in a way, by determining the magnitude of interaction, we can easily make out that how much is the intensity of interaction of a factor A in the presence of factor B. So this indicates that obviously B is affecting the effect of which is produced by the factor A. you see this is the second kind of interaction. And as you can see, this is even more slanting. See the slope, you just observe the slope which is there in this interaction one. This is less steeper. Whereas if you observe this, this is even more steeper. The slope is even more inclined. So that means, and if you will calculate it mathematically, you can easily make out that what is actually the magnitude of interaction effect. So obviously it is going to be more in case of the second interaction. So now just see this third kind of interaction. So you see over here, they're simply interacting with each other. That means obviously they're going to have an interaction with each other. The one factor is going to have an impact on the other factor. So if you if you will calculate the effect or the magnitude of the ultimate actually interaction effect, you will observe that it is even more as compared to the previous interaction. So if you see the interaction one, its magnitude of interaction must be low, then more in this case, whereas it is even more in the case of third interaction. So this is about how we actually analyze the interaction effects by means of design of experiments. Then comes the randomization. Randomization is simply, we do this in case of our normal experiments also. We pick up the things randomly. Okay, we cannot perform the things in a particular order, because otherwise we are not having going to have a control of the experiment. So we do the experiments randomly, okay, and then we analyze them. So randomization, actually its major purpose is that it minimizes the errors that might occur because of actually the runs that we do in an order way. Okay, so randomization is again a critical and an important part. The next thing is blocking. See, blocking is a very important technique, and if you'll work on the now softwares which are available, they have given a specific tab for the blocking also, which is very important, and we must keep 1 or 2 blocks in our experiment to avoid any kind of noises or errors. Okay, so this basically increases the precision of an experiment by breaking the experiment into homogeneous segments. I've told you, like if we are performing an experiment on day 1, obviously the temperature and humidity conditions are going to be different. In the day 2, it is going to be different. So might be that these factors have an impact on our output. So we can avoid by actually forming the groups of by forming the groups. Okay, so that these blocks can be avoided. Okay. Another thing is that by randomization also, this some way these blocking factors can be avoided. Another important key point in this is that we need to run all combinations at one level before running all the treatment combinations at the next level. So in a way, it saves the time also, our resources also. Now, the fourth terminology, which is even more important, is the replication. So see, one thing that it should not be confused with the repeated measurement, right? Replication means we are actually replicating the entire run of experiments. We are not repeatedly measuring something. Like if I'm measuring the viscosity of the suspension, repeated measurement means that we are actually measuring the viscosity first time, second time, and third time. But replication means we are actually replicating the entire set of experiment, and then we measure the things. So these two things are entirely different, and replication is again very important, and this helps us to actually select the significant effects of any factor. Okay, and this also avoids the errors or actually the noises which are otherwise there in the system. So then coming to the types of experimental designs which are there. So see, when we go for any experiment, before designing it, we must do some certain kind of homework, otherwise it saves a lot of time. And the first thing is very important that we do. You must also be doing this. I hope that most of you are actually the participants are the teachers, and they are very well aware that what is actually the role of literature survey when we go for any kind of designing of experiments. So that actually comes under the screening, the pathway, right? So by screening, we select certain set of factors. So those factors are actually recognized by means of these preliminary investigations that we do in our lab, or by means of literature survey. Okay, so on the basis of this, we select certain factors. Then screening designs, again, when we talk of the computer softwares, we put certain major factors out of, like, for example, we have selected 15 factors, and we consider that these 15 or 10 factors are very important for the formation of a particular tablet. Then by means of these screening designs, we again taper this to a lesser point where we actually select the 5 out of these 10 or 15 factors, right? Then the purpose of response surface design comes into play, where we actually try to reach to the optimal settings of the significant factors, where we actually try to select the level or the amount of the particular factor that we are considering for actually the experimental runs. So these two things are very important when we go on for the experimental designs. So this is the general overview. Okay, so this is for the general overview. You can see over here the screening techniques whereby we select certain known factors and the unknown factors. Then on the basis of the preliminary investigations and certain screening techniques, I'm going to tell you what are these screening techniques that we take up. Then we select few factors out of this. Then we study about, we go on for actually the characterization techniques where we go for the factor effects, interactions. Then based on these interaction effects and factor effects, we again move to the response surface methods, that is for optimization, whereby we select only few factors out of these preliminary selected, the vast number of factors, right? Then we go on for the verification to judge that whether the results that we have obtained, they are actually significant enough or not, right? So this is the general the workflow that we must work to go on for the experimentation. So in general, the screening techniques include the Plackett-Berman technique, the fractionate factorial technique, the two-level full factorial technique. This is even adopted at the industrial level. And when we go for the preliminary investigation, we normally rely on the two-level full factorial design. But if we want to reduce the number of runs or the number of the experiments, then we go for the fractionate factorial design. Even in a better way, we go for the Plackett-Berman techniques. But the two-level full factorial and the fractionate factorial is the vastly used technique for screening of the major factors. Now, after the screening of these major factors, we go on for the optimization, which is in which we only select the 2 or 3 major factors. You can see over here the factors selected, they are actually between 3 to 5. So this is generally the limit of the factors that has been selected by the initial screening techniques. And in this, then we go on for the optimization. Then by means of 3D response surface graphs, we actually locate the point where the optimum output or the desirable point is achieved. So this is done by means of Box-Benken design, the CCD, that is the central composite design, and the 3-level factorial design. So that optimization is achieved by means of 3 phases. The first I've told you is the screening, where we actually select the major factors. Improvement, this is again the medieval important point, that is by repeated changes of the factor settings, we try to select even the fewer factors which have been selected out of the screened factors. The next is actually the determination of optimum, which we do by means of response surface methodology. So that is done by means of CCD, Box-Benken designs. So first, in case of screening technique, the thing that we actually follow is a 2-level factorial design. Most of you, I suppose that you must have even worked on this, the full factorial design. So in case of full factorial design, it is very important because in this we perform the entire runs and we study about the interactions, any kind of interaction, if it is there between the factors, that is actually evident by means of this full factorial design. Second is actually the fractional factorial design, in which it is the one in which we only study about the main effects. Okay, so again, I'm telling you that if we have to do it manually, then it's actually entirely a very difficult process. But if we have to do it using the computer software, then this is again a very easy process, because they just find it out for you, the major effects, the main effects, they draw an equation out of it, and then on the basis of that equation, you can easily locate which are the main effects, which are the interaction effects, which are the individual effects. Then you can, on the basis of these main effects, you can draw a fractional factorial design in which the number of experiments are actually even reduced further. So you can see this is, if you'll work on the STATI software, the design of the design expert software, whose actually so many versions are now available. So this kind of window actually appears. So you can see over here, this 2, 3, 4, 5 up to 15. These are actually the factors that are to be taken up. And these 4, 8, 16, 32, 64, these are actually the number of experiments that come up. So if you want to come up, this is actually a mathematics matrix system. So those who have studied about the mathematics, they must be aware that how we actually draw the number of experiments out of the matrix by using the factors. So if in case of the two, if we are taking up the two factors and this white line which indicates a full factorial design, so this at this end it indicates the number of experiments that we'll be doing, in this case will be 4. If we talk of 3, in case of full factorial design, it is going to be 8. So the general relationship between the factor and the level is actually 2 to the power n. Okay, so whereas actually 2 is the level of factors and n is actually the number of factors. So then you see over here the white line, in this we just do the full factorial. Then these, the half factorials, you can see the green ones, they are actually used again for optimizing the screening purpose, and in this the number of experiments gets reduced. But as you will move further, you will see over here, as we increase the number of factors, it becomes even more complicated. So the red region, the one which is being indicated over here, it is not never to be performed. We never normally perform these experimental designs because they are used only in a very rare cases. Normally we just stick to the green patterns which is shown over here, the white for full factorial, and for fractional we do the green colored the box designs. So simply what you will do, the moment you're going to click on these boxes, the kind of design that you want, the entire table will come up, and based on that you can design your experiments and perform them and feed the outcome or the result into or response into that, and you get the result. Now the way, see, actually initially I just wanted to tell you about the softwares, how to operate them, but I think I thought of explaining the how to do the analysis part better, in a better way, because that you can do the handling of software is a thing that I think anyone can do, even the kids are performing so well. But the thing which is more important is the analysis part which we are doing. So I thought of emphasizing more on the analysis part. So in case of these experiments, we get the output in the form of different kinds of plots which are there. So the one plot is actually the half normal plot, and this is also known as Daniel plot. So this actually, see, if we have to produce this plot on our own, so this is going to be really tedious. So this computer generates, this design expert software actually generates this plot for us, and simply by looking at actually the color differentiation, you can make out which all factors are producing the positive effect and which all factors are producing the negative effect. And even the thing is that by this way you can easily produce the major results in a really fruitful way. So we can have a quick visualization of the important effects, whether it is in a positive direction, that means it is increasing the particular response, or in a negative direction, that means it is decreasing that particular response. So we can have a linear relationship between actually the response and the independent variables. So another thing which is very important in case of this design of experiment is that if we have to draw the linear relationship, which is otherwise there in the case of one factor at a time approach, this linear the experimentation is being avoided in the design of experiment, because otherwise we are not going to achieve the optimum in this. See, this is the approach. We change the settings which are there with us. We try to improve them by making certain changes in the levels of these factors, and then we try to achieve the optimum. So this is the general pathway that we follow. So this is the regression models that we use for optimization. These are the general line equation. You must all be aware that this is y equals to mx plus c. So this is generally used to indicate the linear relationship between the any two things. Okay, so but in case of design of experiment, we normally go for actually the curved lines, the quadratic model, so that we can have a better fit and we can have a better visualization of the optimum point. So this is the thing that I want to explain you, that if, for example, this is the model, right? So this is the optimum point, this upper red end, and this is the lower end. And then you see, this is the kind of results that we obtain. Then how we are going to relate it? So normally, in case of earlier method, we used to relate it by the linear modeling process. So by this process, we are never going to achieve this curved line, which is otherwise the optimum point, right? So this is, again, the linear model is not required. It is far from optimum. This is an example of first order model. Now, if we take up the another case, again, the similar optimum point is there that we need to achieve. These are the points which have been achieved by using the multiple interaction effect factor studies. Again, it is not near to the actually a major result optimum point that we want to achieve. So this is actually the first order model, and again in this the curvature is not being reached. So again, after the linear, this is again a somewhat linear point, the first order model, which doesn't give the exact results to us. So this is actually the quadratic model, whereby we try to the multiply our major, the individual effects and the interaction effects in such a way that we get a quadratic model out of it, and then we get the near optimum results out of it. So you need not to worry that we need not to do the calculations out of it. The computer is there, the computer is going to do all calculations for you. This is just for the basic understanding that how our second order model is actually helping us to achieve to the optimum. So then comes the replications. I've told you that replication is very important to avoid the errors, and sometimes it's important to add the center points into our experiments. So see, if this is the case, normally in case of such kind of experiments, we classify our experiment in the form of a design space, where we arrange certain low levels of factors, the higher level of factors you can see over here. The low is represented by -1, then +1 is for the higher level, and then similar is the case with another factor which is actually not visible in the window, the A factor. Again, at this point, it is actually, if you follow the cursor, that this is actually the -1 point, this is the +1 point for the factor A. So we normally put a center point, the medieval point into it, so that we get actually the curvature line, the result out of it. Again, this is not an issue because the computer is going to do all this for you. The only thing is that you need to put the center point into your experimentation. Then comes the multi-layered experiments, which we actually do, and which we actually need to do because we cannot rely on the one factor at a time experiments for long. So in this, we do for actually the initial experiments by means of checking out the experimental equipments, getting the initial values for quantities of interest. Then we perform the main experiment, whereby we try to achieve the major goal of our experiment. Then confirmation experiments, whereby we, after the screening, the optimization, the third is actually the confirmation, where we try to verify the results which have come up from the main experiments. Okay, so this actually helps us to reach to the optimum, the best point. So for example, if we see over here, if we want to test any material for the material hardness, see what are the factors which could be involved, the force involved, the pressure which is there for the pin, the pressure which is being applied using this pin. So in this, the one factor which is very important is the tip of the pin. Okay, the another is actually the strip testing material which is to be tested, right? So the practical problem in this case is that although we are looking into everything, but we cannot avoid the tip of the pin, which is an important point for testing actually the material hardness. So how we can design actually the experiments out of it. So if you see over here, this is experiment design 1, whereby the testing strips have been arranged in this order. So 1, 2, 3, 4, 5, 6, 7, 8. They're the other ones, 9 to 12, 13 to 16, and these are the pins which are there, the pin 1 to 4. So in case of such kind of experiment, actually the thing is that because we are using the 4 types of pins, we are using the testing strips, even they are different. So if for example, the measurement of strip 5 through this 8 point, it might be caused, the difference in the results might be caused because of actually the difference in the pin 2. So otherwise means the kind of results that we are going to get out of these kind of experiment would be so clumsy and difficult to interpret. So designing it is very important. So in that case, what we can do, the second kind of pattern you can observe over here, where we will take up the similar 4 strips, okay, the pressure pins, the strip 1, 2, 3, 4, and these 1, 2, 3, 4, they represent the pressure pins. So they are, again, you follow this, that they are arranged in a random order. Here it is 1, 3, 2, 4, here it is 1, 4, 3, 2, in a different way. See, you need not to arrange these things. Computer will do this for you, but the only thing is that you need to understand the basic fact about the randomization and how the experiments are to be designed. Then comes the next thing, that is the advantage of the blocked experimental design, is that it gives actually the relationship in such a way. For example, if we'll work on it, we are going to, this y actually represents the response that we want, the effect of that on the hardness of that, the ultimate hardness, and these coefficients actually represent the different the effects, the error terms that that is being this we need not to calculate. This again the computer is going to do to us, but we need to interpret the results based on the coefficient values that we come up, whether it is in a plus or a minus, that indicates the positive effect or the negative effect on the ultimate response, which is the y. So in a way, I just want to show you that the fractional factorials are used for initial screening, or the full factorial designs. Again, they are sometimes used for the initial screening of the factors, but then this is followed by the high resolution fractional designs, the response surface methodologies. So if you follow my cursor, you can see this is a mountain peak. So we want to reach to this peak, which is actually the optimum. So these screening techniques, they actually help us to reach to this peak. They show the path, but the peak is actually achieved by means of the response surface methodology, which is by the central composite design, the box penguin designs, and by means of how do we interpret the results, by means of the 3D contour, the 2D contour maps, the 3D response surface graphs. They actually help us to locate the regions which actually the optimum point. And one more thing, that they should not be the saddle points, they should show some kind of peak, so that the maximum can be the optimum can be reached on. So this entire mountain range is our area of work. The path is actually being shown by the screening techniques, and the top is being reached by the response surface methodology methods. So this is the case when we talk of one factor at a time. You can see if this is the factor 1, then this is the response. We can just study about the one factor. This is the factor B. You follow the, if you're following my cursor, this is the effect of the factor B on the response. Then this is the kind of graph which is being obtained. So we cannot study the interaction in this kind of graph. Whereas if we study the response surface methodology, these kind of 3D graphs are being obtained. These are the contour plots at the bottom. So we can really actually study about the kind of interaction that we want, and then we can look for, this is not a saddle kind of a graph, this is an this is in an increasing order, the peak kind of graph is there, and then by using the optimization, using the software, you can even locate these points manually and can select the best option out of it. So another, the optimum, the output results that we can look for, they include the effects like half normal or the normal plots. They are used for highlighting the active factors which are there. Then Pareto charts are also there, getting colored in a different way, so that you can actually study about the intensity of the effects which are produced by these individual factors. Then again, no doubt ANOVA is because when we study about the one factor at a time, then a single one-way ANOVA is there. But in this, we normally do the two-way ANOVA in case of these design techniques. Then we get actually the summary statistics in this case, where we try to obtain the signal to the noise ratio, which actually measures the ratio of the range of variation which is there. And then by this also we can determine about the percentage of bias. Bias means the amount of the result which is there actually expected, and which is means the predicted and actually the actual response that we have observed. So that percentage bias calculation is even very important. Then as I've told you, that we fit the model into the particular equation, and on the basis of those equation coefficients, we can actually determine the intensity of the individual effects, even the interaction effects, by using the quadratic models. Then even we can go for the diagnostics using the residual plots, and Design Expert is one such software which does it very wonderfully. And you can even go on for the trial versions. They are also helping you out in a number of ways. We have the Box-Cox plot, and then the plots of leverage, the influence statistics. All these actually the diagnostic part, they help you about the intensity of effect that each individual factor is producing on the ultimate result. Then we have the model graphs in the form of the 2D contour graphs, the 3D response curves, which help us to analyze our results and reach to the optimum. Then we have the one factor effects. I've shown you the graph for this. Then interaction effects, that graph has also been shown to you, where you can study about the intensity of interaction, that how one factor is affecting the another one. Then we have the contour graphs, then we have the 3D surface graphs, even the cubes are there by which we locate our design space. So these are the certain things that are to be kept in mind while going for design of experiments. We should clearly state the objective of experiments. We should look for the factors, its levels, its values. Then we should look for the appropriate blocking. The biases should not be avoided. Then we should again look for the non-linearity, because we cannot achieve, I've told you that we cannot achieve the optimum using the linear model. So we need to rely on these quadratic models. There are a number of softwares which are available which work for it, because again this is another part of a talk where we need to work on the softwares, how they actually work. And believe me, they are so wonderfully designed that once you click on it, you are going to actually work like wonders. So there are a number of different softwares like Stat Graphics is there, Statis is there, Six Sigma is there, Minitab is there. When we started with it, there was only the Design Expert was there, the Statis was there, but now even much better softwares are now available which you can work on. So even other softwares, other aligned softwares are like Optima, Statistica, Omega, Design Expert, Compact, SPSS. So many versions are available: Matrix, Minitab, XStat, eChip. So like you can get an ample of softwares on which you can work. But I will personally means I cannot like recommend anyone. But personally, I have been using Statis and Design Expert, and they are wonderful softwares. You can work on it. Then the thing is that before selecting any software, you must be able to understand that it must be reckless and accurate. The interface which has been obtained by using the graphic details must be friendly, and they must be understandable to use. There are a number of tutorials which are available by which you can easily grasp the information about the kind of results that are obtained. Then another thing which is very important is that the noises cannot be avoided, but you can keep them to minimum by means of randomization or by means of replication of your experiments. See, I initially I just wanted to explain about each of the software, but I thought of explaining about the major results, the analysis part. But if anyone is having any kind of like query relating to the design, they can contact me anytime, and we can say that these QBD-based approaches, the statistical softwares which are available, they have really widened our horizon of thought on designing. And these are really effective tools which are high quality, cost effective products, and they allow us to get the maximum of information with minimum number of runs. And the reproducibility is so high, the precision is so high that you get the results out of it. So definitely, if you're going to work on it, you're going to get the cake beautifully done, very tasty cake out of it. And thank you so much for the patient hearing. And like if anyone is having any doubt, you can say. And even I have provided in my first slide my email ID. You can contact me relating to the designing also. I would be more than happy to help you in designing your experiments. Thank you so much.
Thank you very much, ma'am. And there are some queries from the side of the participants.
Okay.
One of the participants want to know when we use in this in analysis department also these type of the technologies.
Yes, you can even the analysis, analytical studies you can perform using these experiments. You can work on cell culture techniques, and then you can optimize your cell culture experiments using these experimental techniques. Means this is a wonderful, like the software is so easy to work on. And like if you have any query relating to experimental designing anything, you can contact me anytime. Like I'll be more than happy to help you out.
Ma'am, there is a participant Shilia Das, and they ask
Okay.
if lack of fit is significant, what we can analyze in the research RSM experiment response surface methodology experiment will accept or reject. Minimum how many replications is required to get a correct result? If no of factor 5, if number of factors are 5.
See, I will suggest, who is this? Like, can you name
Shailya
her?
Das.
Okay. Shailya, like, I'll suggest you, like, if you want to go for such kind of experiments, you need to reduce the number of factors. Like you are saying the 5. I have told you in my slide, like, you need to go for, you need to go for screening, because, if you'll go for the factor 5, it will be very difficult to work on all the experimental runs that you need to work on. So I will suggest that you must reduce them using the fractional factorial design technique. You screen out the maximum factors, and then at the end, you just select 3 factors at a time, right? And then you talked about the lack of, what was the next question, that how many replications we should have. So I think we should go for at least minimum 3 replications at a time for each individual experiment. That will reduce our error.
Madam, next, Shailya Das also want to know, by observing the p-value, let the p-value is 0.0006, can I decide the experimental data are manipulated?
So
if the p-value is very less, near to the 0, then we can say the data is manipulated.
See, we cannot question the other persons who is representing. Like, normally, if it is 0.000 something, it is near to 1. So obviously, it indicates that it is highly significant. But as you was like, we cannot question the the integrity of the other individual who is presenting the data. Means I cannot question the integrity of other person. Otherwise, like, if it is the P is coming out to be significant, then obviously the results are good. But that depends on the integrity of the individual person who is presenting the work.
Ma'am, Dr. Dipti B. Patel wants to know, is QBD studies and DOE are same or different?
Actually, DOE is under QBD technique. Okay, the quality by design, it is a major broader term, and this DOE are actually under QBD. These are the QBD approaches.
Preeti Jain was want to know, are these softwares which you described good enough for QBD design and analytical and bioanalytical methods?
Yes, you can use them for that purpose also. See, because I had been to US, and there one of my, like, there it is not like that we are from different department. All the people, they work together. Okay, so we had the people from the analytical background with us. We were from the pharmaceutical, the formulation development department, and we used to work together. And even they used to prepare, to optimize their data based on the analytical studies, and other things. So we can use that for that purpose also.
Mr. Ashwani Mishra want to know, there are very much softwares, but they are also in the licensed versions. So there are any free web servers or the free softwares that can be utilized in the optimization?
See, personally, even I don't have the original, the version of anything. I'm even using the trial version. Like, it has been last 16, 17 years that I'm using the trial versions. And believe me, I'm not having any kind of issue with any of the software that we are using. The Statis is there. Like, if you give the good results, even Statis people contact you, and they sort out the issues which are there, like while during the experimentation thing and other things. So I think trial version is equally good. Like, you can go for it. Although for the purpose of experiments that we perform in our lab, I think they're sufficient enough. We can use the trial version.
Madam, lot of the participants says the very nice presentation and very useful for them, and some of wants that you organize some hand-on training program on the DOE for the participants also.
Sure. Like, you have my email ID. I will request Dr. Shailesh sir to share my email ID. If you have any kind of query relating to design expert, you can contact me anytime. I'll be more than happy to help you all. Thank you so much. Thank you.
Thank you. In the conclusion of this expert talk, I can say the industry experts and the regulatory bodies agree that the design of experiment is an essential element in the drug product development nowadays. The DOE is an effective method for evaluating the products, parameters, and identifying the critical parameters that need the consideration during product optimization and development. Unlike the conventional methods of evaluating one variable parameter at a time, which can sometimes provide incomplete information when other parameter exists, the DOE allows for the simulation evaluation of various parameters as well as their interaction and influence on the target product parameters also. By using the DOE, there is an increased probability of product success because of the large data set that are generated systematically and evaluated statistically. The benefits of the design of experiments in pharmaceutical product development are the reduce the development time, performance of the product is increased, process robustness is maintained, and cost cutting of the product. By using these approaches, we are able to see the virtual product on a paper on a computer. Unlike the trial and error methods, a systematic product design approach that use the simulations, softwares, and algorithms can reduce the conventional experimental methodology, hence bringing the substantial time and cost benefit when optimizing a formulation. Thank you very much, ma'am, for being with us and enlighten a very novel and new technologies in the development of the pharmaceutical dosage forms and development of the product. And this is the current need of the industry also. So we are very thankful to you, ma'am. Kindly, I share a certificate. Once a minute, ma'am. Good. Ma'am, this is a e-certificate to you, a token of love and respect to you, and we share it to you through an email and the WhatsApp. And when the COVID is over, then we send it the hard copy to you also. So thank you very much, ma'am, for being with us.
Thank you. Thank you. Thank you so much.
And dear participants, there is one announcement, important announcement to all of you. That today's second session, which is taken by Dr. P.K. Sahu, Director, DIPSARU, today is not available at 11:30 a.m. due to some important task of them. So his session is conducted in evening at 4 p.m. So the next session will start at 2 p.m. with Dr. Patrawale ma'am from ICT Mumbai on the same topic, the development, dosage form development and computer-aided drug designing. So thank you very much. We all will join at 2 p.m. sharp to receive new messages and new tasks from Dr. Patrawale ma'am. Thank you very much. Hello.